All right, absolute value equations and inequalities. I've got a set of rules here. We'll talk about these different rules. We're going to have an absolute value equal to something, less than, or greater than. And I wrote this with less than or greater than, but we need to remember it could be less than or equal to, greater than or equal to. It's still going to be the same property. Okay? So, as far as solving process goes, you don't need to write these down. Let's see. Get a couple different problems up here. All right, so these are the different types that we've done in the past. So you don't need to write them down, just think about it. Those problems, for the most part, should look easy for you to solve. You should feel pretty confident. Hey, I've got an equation. I'm going to subtract 3, then divide by 2. There's my answer. Does everybody agree with that? Would it make it any more difficult if I threw a -7 there instead of a 7? No, same process. Subtract my 3, divide by 2. Everybody's okay with that? Done that for a long time. Now these two are what showed up previously. Okay? Let's think of the solving process. When it's written like this, that means I would add 1 to all 3 parts, cancel in the middle, and then divide by 2. Right? So if I added 1, I would have -1 less than 2x less than 9, and then divide by 2, and I'd have my interval. That look familiar? And then the last one, I'm just solving 2 separate ones. I'm going to subtract 1, then divide by 2. I'm going to add 5. I don't have anything to divide there. That should look pretty common. Everybody okay there? All right. So our absolute values. We know what an absolute value looks like. It's not new. You see these nice little vertical bars. Okay? If it's an equation, then we set up 2 equations, the positive part and the negative part. So here's an example. Let's say we have the absolute value of 2x plus 5 equals 4. And I'm trying to solve for x here. If I have an absolute value, it's going to set up both the negative and the positive part of it. Negative and the positive. So what I want to do is set up 1 with the 4. So I'm going to have 2x plus 5 equals 4. And then here's the other one. 2x plus 5 equals -4. Now the resulting 2 equations, this should look pretty easy for us to solve at this point. We know how to solve the equation. Not a big deal. The new piece today is when I see equals, I know it's going to split the 2 different ones. The positive case and the negative case. Solving process, nothing new here. Subtract my 5. 2x is -1. Divide, x is -1/2. There's one answer. Subtract my 5. 2x is -9. Divide, x is -9/2. There's my other answer. The equations, I've got 2 answers. One -1/2, one -9/2. Does not matter which one you write first. I just have a habit of always putting the original one down first, the 4, and then I'll write the negative case next. Doesn't matter to me. Less than. If it's less than, it turns into what we call bounded. It becomes that intersection piece, the AND equation. Less than's bounded. So let's say I in turn see this. Let's go 3x minus 1, absolute value, less than or equal to 2. Okay. And the rule, the generic rule just has less than, but less than or equal to are the same thing, right, as far as the inequality is concerned. Okay. My setup, less than is what we call bounded, so it's going to be -2, less than or equal to 3x minus 1 less than or equal to 2. There's our new piece. Our new piece today is the rewrite. Writing it bounded between that negative 2 and 2. Notice the negative case, then the positive case. Solving, we're back to doing what we did before. We're going to add the 1. We have negative 1 less than or equal to 3x less than or equal to 3. Then we're going to divide by 3 now. So negative 1/3 less than or equal to x less than or equal to 1. And when we have our inequalities, we're going to write the answer in interval notation. But the nice thing is when it's bounded, and by bounded I mean, hey, x is trapped between negative 1/3 and 1. It's bounded between those two numbers. It already gives you the inequality. Bracket, negative 1/3, comma 1, bracket. Again, bracket because of the equal to. If I have another case, let's go absolute value 5x plus 3 greater than, let's go greater than 7. Going up here. Okay. If it's greater than, so here's my rule over here, greater than, or likewise be greater than or equal to, it's going to be an or. I always remember greater. Greater, there's my or statement. So now I'm going to write this one as an or statement. Here's my first one. The original, 5x plus 3 greater than 7. Or, again, greater, going to be an or statement. 5x plus 3 is less than negative 7. Okay. Now look at that less than. Remember when we do a negative and an inequality, it flips the inequality? So if I'm going to negate this, it's flipping that inequality to a less than. Same thing kind of happened here. Look at the way it's pointing. And then it points the other way towards the 3, or opening to the 3x when you did the negative. Here, these two really technically do switch, but if you flip an equal sign, it still looks like an equal sign. That's part of what's going on. But now I'm back to a situation that I'm used to solving. I'm going to subtract my 3. So that would be 5x greater than 4. I'm going to do the same thing on the other, or 5x less than negative 10. I'm going to divide by 5, x greater than 4, or x less than negative 2. And this, we still need the interval notation, but this was where maybe we kind of need the graph to look at. I mean, this one's easier. We can tell it's trapped between those two numbers. I'm there. Now I get to the greater than part. Maybe this is where the graph kind of helps me. Okay. So greater than 4. There's the 4. Greater than going right, parenthesis. Negative 2. Less than, coming back left, still parenthesis. And then I write my interval notation. So again, from left to right on the interval notation, negative infinity to negative 2, union, because we had 2 of them here, 2 parts, 4 to infinity. Are you okay there? So, based on what we've previously done here recently, from here down, that should all look familiar. Right? The new piece for us is going to be this rewrite. If we can get it rewritten in the type of form that we need, I get to go back and do the same solving process. I'm just trying to get the rewrite down. Everybody okay with that? Right. So we've done the solving before. See it again. So all I'm going to do right now is look at a few problems with the rewrite. Okay. We're not going to bother solving it. We just want to think about what the rewrite would look like. All right, let's say rewrite. We're not going to solve. We're just going to rewrite them. Let's say absolute value of x minus 6 is less than 8. Okay, so let's think here. Would this be two equations bounded between two values or an or statement? As soon as I see less than, I'm thinking, all right, do I write two equations, bounded or, and less than is my bounded one. So I'm going to be trapped between -8 and 8. Then I'm ready to solve. It's bounded between the two. As soon as I see that less than or less than or equal to. If I had absolute value 2x minus 1 greater than or equal to 4. I thought first goes to, do I split it to two equations? Is it bounded the way this one was? Or is it an or statement? And this one's the or. Again, I think great or. It's reminding me that it's an or statement. So my or statement would be 2x minus 1 greater than or equal to 4. Or 2x minus 1 less than or equal to -4. And then I'm ready to solve. If we can get that rewrite, we're back to the solving process like we did before. That's the nice thing. All right, let's go absolute value 3x plus 2 less than or equal to 1. I know my first step's still going to be that rewrite, so I'm thinking two equations, bounded or. This is my less than, so I'm back to a bounded one. And it's going to be bounded between -1 and 1. Then I'm free to solve from there. Everybody okay with that? Let's look at an equation. Let's see, how about absolute value 2x plus 5 equals 6. Equation is going to give you my two equations. One with the 6, one with the -6. So I would have 2x plus 5 equals 6, and 2x plus 5 equals -6. There's my two equations to solve. And then we're back to solving a two-step equation like we've seen an awful lot before. Nothing new on the solving. Sometimes equations can look a little bit tricky. If I did something like this, absolute value of 3x minus 1 equals x minus 5. I mean, we've seen equations where we've got an x on both sides. That's not new to us. What's new is we're kind of mixing in an absolute value here. Okay. Two equations, the positive or the original. So my first equation would be 3x minus 1 is x minus 5. There's my original one. And then the negative. So when I have a negative, negating that right side. So this would be 3x minus 1 equals -x plus 5. Now the reason it's -x plus 5, we're negating the right side. So that's going to distribute through and give me -x plus 5. As far as the solving process, still back to what we've done in the past. We just got to make sure we have the setups right. So on an absolute value, we've got to pay very close attention. What is showing up right here? This is what's telling me how to do the setup. Less than, bounded between, greater than, or if I see an equals, I've got my two equations. Okay. After I get that set up, the nice thing is we're going back to solving like we did before. Okay. When you get to inequalities, we need to have all of our inequalities, final answers written in that interval notation. Graphing's optional. Okay. I really do think the graphing helps when you have these or statements, when you see them going apart or covering everything, something like that. Okay? But that's still optional. We've got to get that final answer in the interval notation. Are you okay with that? Any questions about solving one of these 5? Okay. All right.